Hi, this is a presentation of CCNA1 Chapter 10 about the application layer and the application layer protocols. So let's have a look at where we are now. We are in the upper layers in either the OC model or the TCP/IP model. We can see here that in the TCP/IP model we have one large application layer, whereas in the OC model we have three upper layer. So the session layer, the presentation layer, and the application layers is put together in one layer in the TCP/IP model, which is the one that we are using. On the application layer, we will see that we, for instance, have the DNS, the HTTP protocol, the SMTP protocol for mail, POP office or post office protocol for mail, dynamic host configuration protocol or DHCP for handing out IP addresses, file transfer protocol, and the internet messaging access protocol. These are typically protocols that will be in the application layer, both in the OSI model and in the TCP/IP. In the TCP/IP model, we don't really have any layers that will cover the presentation layer and the session layer. The presentation layer will take care of the conversion between different types of application layer data. That could, for instance, be conversion between two different formats. For instance, in images or video or whatever it could be, so that it can convert from one image format to another. It could also take care of data compression and also encrypt and decrypt of data. Some of the application layer protocols in TCP/IP can take care of some of these, but they don't really do that. And also we have the session layer, where it will take care of the dialogue between the source and destination. It handles the exchange information of the dialogues that initiate the configuration or conversation between them, and keep them active, and even if you need to restart them, the session layer can take care of that for them. In some of the programs that we are using today, these functions will be taken care of by the application themselves and not the session layer. So here, for instance, we could have some kind of a protocol that could convert from the on the presentation layer from, for example, a QuickTime to a MPEG movie, for instance. But it will be too much to ask of a networking protocol to take care of these conversions, because that's quite heavy traffic. So we really don't use that. If we look at the TCP application layer protocols, as I said, we have the DNS that is used to resolve internet names into IP addresses. We have Telnet, a terminal emulation protocol that will give us access to servers and networking devices so that we can configure them, for instance. We have the Bootstrap and the DHCP, which are both protocols that are used to obtain IP addresses and other things that we need. For instance, the subnet mask, the default gateway, and the DNS that a host will need on the network. The hypertext transfer protocol, the one that we use to send web pages from a web server to a web client, which is a browser, for instance. Then we have the file transfer protocol, FTP, that is used to send files from one system to another. We have the trivial file transfer protocol, which is the same or more or less, but it don't uses any kind of authentication. Everyone can send and receive files if you're using the TFTP protocol. We have the mail protocols, the SMTP, Simple Mail Transfer Protocol, that sends mails between mail servers, but also between clients and mail servers. The Post Office Protocol is used by some clients to retrieve email from a remote server, and you can also use the IMAP for that purpose. When we are looking at these application layer protocols, they can either be peer-to-peer protocols or client-server protocols. If you look at peer-to-peer networks, well then all the devices can either be both a server and a client at the same time, and they are equal. So my computer can be both a server, so I can have some files, for instance, that I will share with other clients, and then I can also ask other clients to request a file from them. So we are both, in this case, both a client and a server at the same time. For instance, we can have these instant messaging protocols where we are both client and a server at the same time, and both clients can initiate a message and receive a message at the same time. And we can see that in this case, the devices that are communicating are considered as equal or peers, so they can do the same thing, both of them. We have some common peer-to-peer applications, for instance, BitTorrent in the way of sharing files. We have Bitcoin. We have other types of file sharing protocols, for instance, or applications, LimeWire, Line, or BearShare. Many of them are based on the GNU-Tela protocol that can enable us to share files that we have on our hard drive, for instance, with others. But the most widely used way of communicating on the application layer is to do it with the client-server model. So we have our device, which is the client, and we can ask the servers for different information. And the client could, of course, be either a computer, but it can also be a mobile device or a IP phone or whatever. So it can be a lot of different things. And then I ask the server for something, and then the information is downloaded to my device. I can also upload things. If I want to share a picture or something, well then I upload it to a web server, for instance, or a FTP server or whatever I want to share it on. Yeah, and that was the first part.